Hello and welcome to this video into which we will see the least square method, not its development but its results. So what is the purpose? First, let's take a point cloud and let's imagine that we draw a straight line through the cloud. Some points will be above the line and some below the line. Well, we are interested in the residues that are the vertical distances between points and straight line. And there will be some positive residues for the points above and some negative ones for the points below. The Myers method that we discovered in a former video um, was in association to the Myers principle. That was that the positive residues must compensate the negative ones to obtain a good line. So it was a weak criterion. It was not enough to find a correct line, not alone, by the way. And this was a problem for having a very accurate method that uses parameters and so on. Well, this time not me, but mathematicians thought about a least square method that consists in squaring the residues and make the sum of the squares of residues as little as possible. Okay, so a minimum sum. This principle was invented by not him. So let me introduce you still Carl Friedrich Gauss, German, a German mathematician who was a monster, of course, who anybody knows, everybody, sorry, and Pierre-Simon de Laplace, French, that maybe everybody knows, and who invented the least square method. So he published a few years before Gauss this method, but they invented it both. Well, there was a little strike between them, and let's imagine now that the principle is the sum of the square of the residues is minimum. So it will make, of course, draw a line that passes through the cloud and as close as possible to the point. It's one principle among others to think about this kind of situation. So let's now see the results. So without any development in calculations here, maybe in a further video. The first result is that the regression line will be unique this time. So instead of with Myers principle. And so we can put glasses on goes, oh, well, no, Laplace will be sad. So let's put glasses on Laplace. Okay, first and the second result now, in any case, G, the mean point of the cloud, belongs to the line. So that's good news because the principle of least square method implies the Myers principle, okay, which was equivalent to G belongs to D. So if you meet this principle, the sum of the square of the residues is minimum, you have another result as an implication, which is the positive residues exactly compensate the negative ones. What is G? G is the point whose coordinates are x bar and y bar. That's all. So the center of the cloud. Well, let's put glasses on Ghost because he deserves it. And a crown? Oh yes, why not? No, no, on Laplace. Okay. Well, the third and last result here will be to obtain formulas and simple formulas to calculate the slope and the y-intercept of the line. If you divide the covariance of x and y by the variance of x, you obtain exactly the slope of this line. And if you calculate y bar minus a times x bar, you obtain the y-intercept. So in a French notation of an expression of a line, which is y equals ax plus b. Okay, not the English one. So let's put the crown between them so everybody's happy. Well, let's see it on an example, and of course, as you can see, you have to know how to use your calculator to obtain all of that. A first way would be to use these formulas, okay, so to be able to calculate a covariance, a variance, and then to calculate A and B. A second way will be to obtain them directly on the calculator. So it depends on the way the question is asked in an exercise. Maybe the exercise asks you to calculate them, so you have to use these formulas. Maybe the question asks you just to give the expression of the straight line, so you just have to read A and B in your calculator. With exercise 10, we're following the evolution of the expense. So, sorry, it's in French here. The expense of a company in advertising. And here it's given in thousands of euros, 41,000, 60,000, and so on, through time. It's a time series, but still it's a bivariate series. We can graph it, and to simplify the fact to enter data in the calculator, let's name 1, 2, 3, 4, 5 the values of x. So let's number the years like that. So as you can see, you've got a point cloud that shows a positive evolution globally of the expense through time. Now, we can enter this data series in our calculator, like in the previous video, entering in list 1 the values of x, 1, 2, 3 until 12, and in list 2 the values of y, 41, 60, 55, and so on. You've got to check the settings of your calculator, of course. The X list is list 1, the Y list is list 2, and there is no frequency list. You will obtain these results among others, so the mean of X, the mean of Y, the number of pairs XY, the sum of X squared, and so on and so on. And then, thanks to that, you are able to calculate variances and the covariance. The variance of x will be the sum of x squared divided by n minus the mean of x squared, so 650 divided by 12 minus 6.5 squared, result being 11.91 approximately. The variance of y the same way with y, this number divided by 12 minus this one squared, and the covariance is the sum of x, y, so 10,510 divided by 12 minus the product of the average values. Result 84 approximately, which is a positive result, and that shows you that yes, indeed, the global trend is an increasing function of y with respect to x, so of the expense through time. Now, the additional formulas for A and B. A equals the covariance of xy divided by the variance of x, 84 divided by 11, so take decimals, of course, and then you will obtain a result which is approximately 7.0629. B equals y bar minus A times x bar will be approximately 37.42. And then you can write the expression of your line with the French way to express it, y equals 7.06 x plus 37.42. After that, you are able to draw, or you must be able to draw this line on the graph. Just choose two different values of x and calculate the two different values of y and place the two corresponding points. For instance, if you take x equals 1, you will obtain y equals 7 plus 37.4, so 44.4 approximately here. And if you take x equals 10, you will get y equals 70.6 plus 37.4, so approximately 108. So for x equals 10, 108, we are here approximately. So the line, yes, it's this one. You can check that the mean point of the cloud belongs to this line. So it was obvious because of the calculation of B, but still we can check it. X bar equals 6.5, Y bar 83.33, G is the point whose coordinates are X bar and Y bar, so 6.5 83.3, and it leads to a point of the line. Yes, indeed. So now, how could we read A and B directly on the calculator because it calculated them? If you ask a linear regression to your calculator, that's simple. In calc, for the case you have to ask a regression and choose x, okay? So that means asking a linear regression to your calculator, and then you have to choose between ax plus b or a plus bx. So the French notation or the English notation of the expression of a straight line. So you can ask for ax plus b if you want to see that, or the correct coefficients a and b in the correct order. In Texas, you have to ask a linear regression, so it depends on the models. It can be named linreg or reglin, ax plus b if you want it in the same order. Okay, that's all for that. You now are able to find the expression of a straight line thanks to least square method. Thank you and bye, and see you in the next video.